Today we will be looking at formation of ionic compounds. We will use the Lewis dot diagram, the Bohr diagram, electronic configuration, and the Octet Rule. Group 18 elements or noble gases are non-reactive because they have a completely filled outer shell. For elements 1 to 18, it is obvious that in most of the compounds that are formed, the number of electrons in the valence shell is 8 after bonding. So the tendency would be lose electrons or gain electrons so that they will have 8 electrons in the outer shell. Hence it's called Octet Rule. So this leads us to believe that elements undergo chemical change to obtain a completely filled outer shell or valence shell. However, this is not true for a lot of compounds. We still refer to this observation as the Octet Rule, which means that elements tend to combine such that they gain 8 electrons by losing, gaining, or sharing electrons. Now we will look at Octet Rule in ionic compounds. Ionic compounds are formed between metals and non-metals. That's very important. When you see the formula of a compound, the first thing you have to look at is the compound an ionic compound or a molecular compound? So your explanation will depend on that. Metals tend to have 1, 2, or 3 electrons in the valence shell. So it's likely that they lose the electrons to change into positive ions, whereby the ion that is formed will have a stable octet in the next energy level. That's what happens. So for that reason, metals tend to lose electrons and change into positive ions so that the positive ion will have a very stable electronic arrangement. Non-metals, on the other hand, have 5, 6, or 7 electrons. Instead of losing the electrons, they tend to gain 3, 2, or 1 electron and become the charged atom, which we call an ion or an anion. If it gains 1 electron, it becomes -1 charge. If it gains 2 electrons, it will be -2 charge. And if it gains 3 electrons, it will be -3 charge. So that's how the charges are represented, depending upon the number of electrons it has gained. Positive and negative ions are held together by electrostatic forces of attraction, which we refer to as the ionic bonds. We already know that opposite charges attract. Therefore, ionic compounds, because of the very high electrostatic force of attraction, usually have very high melting points and boiling points. Ionic bonds are very strong. Here is a look at the periodic table. I have put the numbers of the groups on the top row. I have chosen group 1, group 2, 13 to 18. I have not included the transition metals here for simplicity, because we will be looking at compounds that are formed between metals and non-metals, between group 1, group 2, all the way to 18, not including the transition metals. In the second row, you will see 2 sets of numbers. In brackets, you will see a number. That is the number of electrons that are present in the valence shell. For group 1, there will be 1 electron in the valence shell. And if it loses that electron, it changes into a positive ion. That's the second number. So group 2 elements will have 2 electrons, or you can put 2 dots around the atom for a neutral atom. Aluminum, for instance, will have 3 electrons in the outer shell and will gain a 3 positive charge by losing all 3 electrons. So group 13 elements will have 3 electrons outside. Group 14 elements will have 4 electrons. Group 15 will have 5 electrons. And when they change into an ion, they gain 3 electrons and become -3. Group 16 has 6 electrons in the outer shell, will gain 2 electrons and becomes an ion with a -2 charge. Group 17 needs 1 more electron, gains 1 electron, and becomes negatively charged. Group 18, since it already has a completely filled outer shell, has a valency of 0. So you can use the periodic table to draw the Lewis dot diagram based on this assumption that we have here. First, we will look at the formation of sodium chloride, which is an ionic compound since sodium is a metal and chloride ions or chlorine is a non-metal. We are going to look at the formation of a positive ion and a negative ion. Sodium being the metal is going to lose the electron and change into a positive ion. Chlorine being a non-metal would gain an electron and change into a non-metal. Let's look at the reason for the representation here. Sodium atomic number is 11, has 11 protons, 11 electrons. The valence shell will have 1 electron because in the first shell we have 2 electrons, in the second shell we have 8 electrons, makes it 10, and the last electron is in the outer shell, the valence shell, and that is represented as a dot along with a symbol. Similarly, chlorine atomic number is 17, has 17 protons, 17 electrons, and the valence shell will have 7 electrons. So the first shell has 2 electrons, the second shell has 8 electrons, and the last shell or the valence shell has 7 electrons. And in the Lewis diagram that we have shown here with the symbols, we have 7 dots surrounding chlorine. So we have only shown the electrons that are present in the outermost shell or valence shell. Now we already know that metals like to lose electrons, so sodium is going to lose that electron from the outer shell. And chlorine needs 1 electron. So the electron that is lost by sodium is going into chlorine atom, and then they change into positive and negative ions. After that, the electrostatic forces of attraction will operate, bring them together, and they form sodium chloride. Let's look at how this happens. The electron from sodium has gone to chlorine. Now they both change into ions. The sodium changes into a sodium positive ion and chlorine changes into a chloride ion. The name also changes. Sodium remains sodium, but we say sodium ion. Chlorine changes to IDE, chloride ion. Now let's look at the electronic configuration. For sodium, it is 2,8. The outer shell, which had 1 electron, is empty now, so we do not include any dots around sodium within the brackets. On the other hand, on the product side, we have added an electron. There are 8 electrons on the third shell, and that is represented there because in a Lewis diagram, we always show the electrons that are present in the outermost shell or valence shell. Now, since we have a positive ion and a negative ion, they're going to come together because the opposite charges attract, and they change into sodium chloride, the ionic compound. We're going to look at the formation of calcium chloride. Calcium is a metal, belongs to group 2 in the periodic table. Chlorine belongs to group 17. We have already seen it. So let's look at the atomic number of calcium, which is 20. Has 20 protons, 20 electrons. Therefore, it should have 2 electrons in the valence shell. So the first shell will have 2 electrons, second shell 8 electrons, third 8, and the last one will have 2 electrons. So we have 2 dots following the symbol for calcium. For chlorine, again 17 protons, 17 electrons, and 7 electrons in the valence shell. So 2, 8, 7. The 7 electrons are represented in the 2 chlorine atoms. The formula says there is 1 calcium and there are 2 chlorine atoms. So we have drawn both of them. Now, if you look at the number of electrons in calcium, there are 2 electrons. And chlorine requires only 1 electron. So the second electron still has to be used. That's why we have taken the second chlorine atom. Now, when you transfer the electrons from calcium to chlorine, we get 2 negative charges. Together, it makes it 2, total of -2. And the charge on calcium is going to be +2 when it loses 2 electrons. Let's see what happens. Now, calcium changes into Ca2 positive, it's calcium ion. Chlorine changes into chloride ion. There are 2 chloride ions. Each of them have a -1 charge. So the total charge is going to be -2. Opposite charges attract and they come together because of the electrostatic force of attraction and change into the compound calcium chloride. Now the electronic configuration of calcium now changes to 288. Outermost shell is empty. Therefore, we do not include any dots around calcium. But in the case of chloride ions, we still show the electron dots because there are 8 electrons surrounding the chlorine atom. So that's how the calcium chloride ionic compound is formed. Let's look at the formation of aluminum oxide. There are 2 aluminums and 3 oxygens here. Aluminum atomic number is 13. 13 protons, 13 electrons. Therefore, the valence shell will have 3 electrons. 2 electrons in the first shell, 8 electrons in the second shell, 3 electrons in the third shell. Therefore, 3 dots surrounding aluminum. In the formula, there are 2 aluminum atoms. Therefore, 2 aluminums are drawn. So totally, there are 6 electrons in 2 aluminums together. On the right side, you have oxygen. Atomic number is 8. 8 protons, 8 electrons, and the valence shell will have 6 electrons. So 2, 6. 6 is the number of valence electrons. We have represented the 6 electrons with 6 dots. Since there were 3 oxygen atoms, each oxygen atom will need 2 electrons. Totally makes it will need 6 electrons. And aluminum can provide 6 electrons if there are 2 of them. Let's see what happens to the electrons one at a time. Oxygen will get 2 electrons from the first aluminum and change into an oxide ion. We added 2 electrons, therefore the charge is -2. Now, the aluminum still has 1 electron, and the second oxygen atom needs 2 electrons. We take 1 electron from the first aluminum and the second electron from the second aluminum. So we get the second oxide ion and an aluminum ion. The third possibility, or the third oxygen atom, will take 2 electrons. And finally, we have 2 aluminum ions with charges 3+ and 3+, making it a total of 6 positive. Similarly, oxygen has -2 charge. 3 of them makes it -6. Together, the total charge is 0 when you bring them together. Now, because of electrostatic force of attraction, which we call them as ionic bonds, they change into aluminum oxide with the formula Al2O3. So that's how we explain the formation of aluminum oxide. So we had taken 3 examples: sodium chloride, calcium chloride, and aluminum oxide. That's it for now.